Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous videos, we have seen the intuition behind the log-level model. We have seen videos on the mathematical derivation, the exact formula, and the approximation, and when to use each of them. So in this video, we're going to give an actual worked example and see a contextual interpretation of the coefficients in the log-level model. So suppose that we estimate a model that now looks ln of wage equals to 2.5 plus 0.08 education. And we're keeping the same information that we've had before. So wages is in pounds, and we've got education in years. Okay. Let's use the approximation interpretation in here. So the slope is beta 1 hat, clearly 0.08. And the approximate percentage change, it's going to be 100 times 0.08, which means it's 8%. So the interpretation in this case will be a 1-year increase in education increases wages by approximately 8%. Okay, that's the quickest and easiest interpretation. Now, what if you were asked to use the exact formula? So let's do that as well, and you can see and compare the two of them together. So using exact formula, then we would have had 100 times e to the power 0.08 minus 1, which this e to the power 0.08 all by itself is approximately 1.0833. So the entire expression in here is approximately 8.33%. So the exact percentage effect is 8.33. When we use the approximation, we had the 8%. You can see they're very similar. And as we said, like whenever we have betas that are small, that's why we do the approximation, because they are going to give us like similar numbers. So for small coefficients, again, the approximation is very close. What would happen though if we have a larger coefficient? And we can very easily show that as well. So let's assume that beta 1 hat is, instead of 0.08, a bigger number, 0.3. So if we used the approximation way, this is going to be 100 times beta 1 hat, and that would mean it's 30%. If we use the exact formula, so approximation, and if we use the exact formula, this is going to be 100 e to the power 0.3 minus 1, where the e to the power 0.3 approximately by itself is 1.3499. So this entire expression would be approximately 34.99%, so almost 35%. So you can see that the approximation in this case is noticeably different. Very clearly here, 8.33, in here 30, 35 almost. So this is why the exact formula matters for large coefficients. So overall, we can now close the little mini arc of the log level model. And you should have learned by now that if the coefficient is small, you can use the approximation and do the interpretation 100 beta 1. Or if the coefficient is large, you can use the exact formula to compute the actual effect. Keep in mind, this interpretation applies when x is increasing by 1 unit because in this log level model, we didn't change what was happening or the function form of the x. The x increased by 1 unit. Now, the other thing that you also need to keep in mind is while all of these interpretations are done when x increases by 1 unit, that does not mean that you might not be asked to answer questions. Well, what happens when x increases by more than 1 unit? Okay. In this case, the answer will be quite straightforward because all you have to do is instead of saying 1, you're going to do 2. So using the same here, so let's say in here we have an increase of 2 years in education for the example that we have just given. Then using the approximate way, we're simply going to do 100 and then 2 times the 0.08 beta coefficient that we found, which should give us 16%. And you can also use the exact formula if you want. In that case, the application will be 100 times e to the power 2 times 0.08 minus 1. Okay. So it wouldn't really matter. Once you have the percentage change for 1 unit change in x, you can easily adapt that to any other changes in magnitude you are asked to. I hope this was helpful, and I'll see you in the next video.